Hey, I'm Insane Curiosity scriptwriter, and I'm currently naked. As I stand here in all my natural glory, I can't help but feel a sense of freedom. There's something incredibly liberating about shedding the layers of clothing that society has deemed necessary. But I notice that being naked does come with some drawbacks. For starters, there's no place to put your stuff. And forget about pockets. Clothing served a crucial purpose in protecting our bodies from the elements and predators. Plus, have you ever walked barefoot without your shoes? It hurts. I'm saying all this because there's a question in my mind. What would happen if you were naked in space? Keep watching to see what I found. Pain everywhere. If you're an astronaut, you might want to have a spacesuit to cover your body with. If you didn't happen to have one, your body would freeze, explode, and you would die the worst of the deaths. We all know this, right? There are plenty of sci-fi movie scenes representing the death of an unfortunate astronaut in space. But how true are those scenes? Well, it is indeed true that you die. You die very badly. From a pretty scientific point of view, it's actually kind of fun. If you were an emotionalist being, you would have the time of your life trying to explain what's happening to a dying body out there in space. And let me tell you something, it's even more interesting than how sci-fi movies picture it. We know this because we have some case studies. I mean, we know stuff. Allow me to explain. First of all, your body's not made to survive without atmospheric pressure. You might be wondering why it's like this in the first place. It's the water's fault. The element from which we all depend has a weird characteristic. In the absence of atmospheric pressure, it boils away. Bye-bye, water, it was nice meeting you. Since water constitutes 60% of our body, we would boil away as well. Not the best thing ever. You would notice your tongue and eyes would become dry because all the humidity would leave your body through evaporation. You would be in so much pain because the air would start flowing away from you at high speed, leading your body to ache everywhere. Don't hold your breath. One thing you should definitely avoid if you ever found yourself in these conditions is to hold your breath. Don't do that. You would make everything so much worse. Holding your breath causes high pressures at the level of your lungs. And if you are in outer space with zero pressure, you would cause them to literally explode. I'm sorry, this is the hard truth. You'll expand, but this is not the end of it. Since everything inside you has started evaporating, you will notice a change. You will become twice as big as you are. You will literally pump up, witnessing an expansion from the inside. Your skin is luckily very elastic, so this is not really a problem. You won't explode, but you'll find yourself twice as big and full of hickeys. Yes, hickeys. As if the universe is giving you one giant hickey. What a lovely death. Loss of consciousness. What else? Well, be prepared for the horror movie scene. Everything you have inside will want to come out of your body, and it will do so through all the possible exits. Eyes, nose, ears. And don't let me be more explicit, you can imagine. To make things worse, your muscles won't work anymore. Since they are inflating, the blood is literally trapped, and therefore, you can't move. Forget about saving yourself by reaching the closest spaceship. Probably after a few seconds, you won't be able to move a single finger. For the same reasons, after maybe 10 seconds, the blood will not be able to make it to your brain anymore. Loss of consciousness. That's when you know you're literally screwed. Real case study. At this point, you might wonder, how do we know about all these things? It's thanks to Aerospace Medicine and Human Performance, AMHP. This is a peer-reviewed scientific journal in the field of aviation and aerospace medicine. It was founded as the Journal of Aviation Medicine in 1930 by Lewis H. Bauer and is published monthly by the Aerospace Medical Association. It is the most used and cited journal in its field and is distributed to more than 80 nations. The results on how our body reacts to outer space are taken by studying some special cases of humans that have actually found themselves in such awful conditions. This was the case of Jim LeBlanc, a former engineer that had to spend some time in a depressurized capsule here on Earth at NASA Center. Things quickly went wrong when his pressurization hose disconnected, and he found himself in the middle of a near-vacuum environment faster than you could say, "Houston, we have a problem." While most people would panic and start hyperventilating in such a situation, LeBlanc apparently decided to take it as an opportunity to learn what it feels like to be a human balloon. As his suit dropped from 3.8 psi to 0.1 psi in just 10 seconds, he could feel the saliva on his tongue starting to bubble like a freshly popped bottle of soda. Not exactly the kind of sensation you want to experience while exploring the final frontier. To everyone's surprise, LeBlanc somehow managed to survive the ordeal. The vacuum chamber, which usually takes 30 minutes to repressurize, was blasted back to atmospheric pressure in only 87 seconds. You might think LeBlanc would have been left a quivering mess of human jelly after such an experience, but all he had to show for it was a pesky earache. When asked how he managed to survive, LeBlanc just shrugged and said, "I always knew I had a bit of a vacuum inside me, but I didn't realize it was that powerful." Meanwhile, the supervising engineer Cliff Hess was scratching his head and wondering why the hell there wasn't more information in the space medical literature about what happens when a human loses all pressure on the outside of their body. So there you have it. LeBlanc survived being turned into a human balloon and now has a pretty cool claim to fame. As for the rest of us, we'll stick to breathing in good old-fashioned oxygen. Thank you very much. Before moving on, be sure to like or dislike the video so that we can improve them for you, the viewer. Plus, don't forget to subscribe to our channel by making sure to hit the notification bell so you don't miss any of our daily videos. Turning into ice. Anyway, let's get back to our death. One of the most interesting things that would happen to you as a consequence of the evaporation and boiling of all the liquids in your body is the freezing of your lips, eyes, and nose. They would turn into ice because the evaporation process takes heat away from your body, and an insane drop in temperature suddenly takes in. This is what you can see in most sci-fi movies when the astronauts die in outer space. Then, even more creepy, the whole body would turn into ice in a matter of hours. Floating forever. I genuinely think the scariest part of all this is that nobody will probably ever be able to find your body. It will be floating in the universe for millions and millions and millions of years, a piece of ice that once belonged to the planet Earth. There's actually a perhaps more interesting outcome, though. If you were to die close to the Earth, right above its atmosphere, there's a chance you might end up burning in it, just like meteorites and dismissed space junk do. In that case, you'll be seen as a small shooting star. Or maybe you could die on or close to a small asteroid. In that case, your body will either remain forever on its surface, or you will be turned into a satellite of this piece of rock and metal. You would basically become one of its moons. Isn't that crazy? Before we move on to the grand finale, be sure to stay tuned afterwards if you haven't seen our earlier release on how long would it take to die on our solar system planets. NASA's possible solution to a dead astronaut body. Imagine you're an astronaut on a spacewalk admiring the view of the Earth from above, feeling like the king or queen of the universe when suddenly, bam, you get hit by a micrometeorite. Talk about a buzzkill. Before you can even say, "Houston, we have a problem," you're incapacitated and floating off into the great unknown. But what happens to your body now? Who will deal with it? In his book, An Astronaut's Guide to Life, NASA's astronaut Chris Hadfield discusses the logistics of a death simulation in space. Yes, you read that right. Apparently, even astronauts have a morbid sense of humor. So let's say you're dead. Your fellow astronauts and NASA need to work out what to do with you. It's not like they have a space morgue or a body bag hanging around. The real space issue here is space or lack thereof. Not just lack of personal space, but the fact that a dead body is a biohazard. That's a huge health and safety issue. So what's the solution? Well, according to Hadfield, you'd probably be brought inside the airlock and kept in your spacesuit. Yes, you heard that right. Your final resting place would be your spacesuit. And we're not talking about some fancy deluxe coffin-style spacesuit. No, we're talking about the same suit you were just floating around in like a human balloon. Sounds cozy already, doesn't it? Apparently, bodies decompose faster in a spacesuit, which is not as ideal as nobody wants the smell of rotting meat or off-gassing. That's the last thing you want to be smelling in a confined space with no fresh air. Therefore, the plan would be to keep you in a cold storage area at the station where you can chill out for eternity. So there you have it, your lifeless body floating around in a spacesuit, and everyone else trying to figure out what to do with you. Well, at least you died doing something exciting, right?
How long would it take you to die on these planets? One day we will have to leave the Earth. The sun will become bigger and bigger, and we will have to escape the solar system. This is what we know for sure, and this is what will happen in some billions of years unless we manage to destroy our planet before nature follows its inevitable course. That's one of the reasons scientists are looking for exoplanets and habitable places in the universe. But is there any place like Earth? For example, what would a day look like on the other planets of our solar system? Come and find out. Mercury. If you happen to visit Mercury, you will experience a smaller gravitational field, which means your mass will still be the same, but you would feel way lighter than you feel here on Earth. This is because Mercury is the smallest planet in our solar system. It is located only 36 million miles, 58 million kilometers, from the Sun and is a rocky planet. Despite being this close to the star, Mercury still seems to have room for volatile components, which are basically found only in the atmosphere, composed of oxygen, sodium, hydrogen, helium, and potassium. Despite its proximity to the Sun, Mercury is not the hottest planet in our solar system. That title belongs to nearby Venus due to its denser atmosphere. Even though a day on Mercury equals about 59 days on Earth, your trip wouldn't last anywhere near that long. This is because of the strange changes in temperature that you would experience. The sunny half of Mercury reaches 430 degrees Celsius. It's really hot. But on the other side, the dark one, temperatures drop to minus 180 degrees Celsius. Your best bet would be to find a cozy spot somewhere in between. But I wouldn't want to recommend you do that, because you wouldn't be able to breathe on this planet. The specific atmosphere of Mercury won't allow you to live more than 2 minutes. Maybe it's better to see what the odds of surviving are on Venus. First of all, I'm sorry to inform you that although you won't be bored on Venus, it would feel like you are, because one day on Venus is 243 Earth days long. It's true. The rotation of Venus is such that the planet orbits around its axis in 243 Earth days. Also, you should expect it to be very hot because, as we said before, Venus is the hottest planet in the solar system. Its maximum temperature reaches something like 475 degrees Celsius. Basically, if we ever decided to land on Venus, we should first make sure that we have a really robust spacecraft, or it would melt. But even if we managed to land on the surface, we would have a hard time breathing. In fact, the amount of carbon in Venus's atmosphere is ridiculously high. It's about 154,000 times more than the amount of carbon here in the Earth's atmosphere. Also, the clouds are made of sulfuric acid, which gives them that peculiar yellow color. Oh, I forgot to say that sulfuric acid is toxic, so I don't think it would be a great idea to live there. I mean, you would probably be dead in a matter of seconds. Mars. As is generally accepted, Mars could be our new home. But could it really be? Well, maybe yes, if we manage to make some adjustments to its atmosphere. First of all, we would be happy because on Mars a day lasts a bit more than 24 hours, so the time scale is quite similar to the one we are used to as humans. But this evil atmosphere would kill us because it is mainly composed of carbon dioxide, argon, nitrogen, and a little bit of oxygen and water vapor. Last but not least, we should take a look at the temperatures on Mars. This place is really cold. The average temperature on the red planet is minus 62 degrees Celsius. NASA is already considering what kind of habitation we'll need to survive on the surface of Mars. 6 companies began designing possible habitat prototypes in 2016, with completed prototypes expected in 24 months. All these habitats will likely have a few things in common. They have to be self-sustaining, sealed against the thin atmosphere, and capable of supporting life for extended periods without support from Earth. To get an idea of what to expect, think about the International Space Station. We'll need things like environmental control and life support systems, power systems, docking ports, and airlocks so that crew can perform spacewalks to repair things that break or to add new capabilities. Expect big, robust equipment to travel across the stars to Mars during the first manned mission, and whatever the astronauts use needs to be up for the long journey. Jupiter. Although it is a difficult thing to accomplish, we could in theory land on Mercury, Venus, and Mars if we have really robust spaceships. But what if I told you there's no chance of landing on Jupiter? It's true. Jupiter is a gas giant, and it doesn't have solid ground to land on. It's a huge ball of gas that some scientists have referred to as a failed star. The amount of gas is so huge that this planet is more than twice as massive as all the other planets in our solar system combined, and there's no rocky contribution. The main components of its atmosphere are hydrogen, helium, and cold, windy clouds of ammonia and water. What we can do is orbit Jupiter, fly by it, as for example the Juno mission did along a polar orbit. Jupiter rotates really fast. One day lasts something like 10 Earth hours. Also, I don't know if you noticed the huge red spot on Jupiter, but that's actually a storm. And the bad news is, that storm is bigger than Earth, believe it or not. It's called the Great Red Spot. If you fall into Jupiter, you'll quickly hit the denser atmosphere below, which will hit you like a wall. It won't be enough to stop you though. After about 3 minutes, you'll reach the cloud tops, 155 miles, 250 kilometers down. Here, you'll experience the full brunt of Jupiter's rotation. Jupiter is the fastest rotating planet in our solar system. One day lasts about 9.5 Earth hours. This creates powerful winds that can whip around the planet at more than 300 miles or 482 kilometers per hour. About 75 miles or 120 kilometers below the clouds, you reach the limit of our current exploration. The Galileo probe made it this far when it dove into Jupiter's atmosphere in 1995. It only lasted 58 minutes before losing contact and was eventually destroyed by the crushing pressures. If you made it 429 miles or 692 kilometers down, you would find pressure levels higher than at the bottom of the Mariana Trench, the deepest place on Earth. You wouldn't survive on Jupiter for 1 second, let alone the fact that the temperature is lower than minus 140 degrees Celsius. Saturn. Saturn, just like Jupiter, is another giant without a surface. Winds on Saturn reach up to 1,118 miles per hour or 1,800 kilometers per hour, and I doubt you would make it through them alive. But even if you did, you would need to breathe at a certain point, and that's the real trouble. The atmosphere would be unbreathable because it is made of hydrogen and helium. If you are a warm weather person or looking for a balmy place to retire, you might consider building your home in Saturn's interior. Even though Saturn is a frozen world sitting 887 million miles, or 1,427,000,000 kilometers from the Sun, its core is scorching hot. But maybe you would have more luck on one of its moons. For example, take Enceladus. This small, icy moon captured the imaginations of people worldwide when NASA's Cassini spacecraft saw it spewing plumes of water into space. This water comes from a global liquid ocean concealed beneath Enceladus's fissured crust. As Cassini flew through Enceladus's plumes between 2008 to 2015, its mass spectrometer found a variety of organic molecules, building blocks of life coming from the moon's ocean. Cassini also detected molecular hydrogen, carbon dioxide, methane, and rock fragments hiding within the moon's plumes. Who said that the most comfortable place for us is a planet? Maybe we could live on a moon. Uranus. Let's move on to Uranus. Uranus has a day that lasts about 17 hours, which isn't too far off from ours. But of course, there's again no landing here. And if you dove into its atmosphere, you wouldn't be able to breathe. If you did manage to dive into its atmosphere though, to your surprise, you would notice blue skies, just like home, sweet home. Yet blue skies on Uranus differ dramatically from Earth because here, deadly abundances of methane gas are the cause of these beautiful blue skies. Helium, methane, and hydrogen are an evil combination of elements for an atmosphere. Also, fun fact, if you could smell it, it would smell like rotten eggs. Oh, and if you often wish the summer would last more here on Earth, then living on Uranus might be the ideal situation for you, because it lasts something like 41 years. But if you ever watched the sky with a telescope from your new home, you might notice a pale blue dot, Earth. You might therefore get homesick. And I'm sorry to inform you, the drive back to Earth to visit friends at highway speeds will take around 43 million hours. Neptune. Last but not least, Neptune. How would we survive on it? First things first, there is no on Neptune, there's only in Neptune. Neptune is a gas planet with no surface. To survive inside Neptune, you couldn't go too deep because the heat and pressure would get you. You'd need everything you need to survive anywhere hostile. Air, water, food, energy, waste disposal, a system to keep the high pressure out, or in if you were very high in its atmosphere. In addition, on Neptune, you'd need some kind of flotation system so as not to sink deeper into its atmosphere. For you to die here, it would take less than a second. Neptune has a bunch of ways to kill you: gravity, radiation, unbreathable atmosphere, atmospheric pressure, and cold. It is a true serial killer. Well, that's pretty much all I have to tell you. So now, after freaking out about all the ways you could die on other planets, why not calm down and just appreciate what we have here on Earth? Earth seems to be the perfect place to live. We have a nice atmosphere that allows us to breathe hassle-free. We have the perfect distance from the sun, which gives us energy and perfectly regulates our sleeping patterns. It is also the only planet where we have Coke. So hopefully we won't destroy our planet. And if we do manage to, we wouldn't have too many opportunities to find a suitable home anytime soon. Scientists are, of course, working on that. But even if we found some extrasolar planet that seems good for hosting life, the problem would be how to reach it in a reasonable amount of time. Probably it's all a matter of technology, and we just have to wait until someone comes up with a clever idea. Until then, the only thing we can do is treat our planet well. Thanks for watching.